Hello guys, welcome to the video. I am Ashish Patnaik and I welcome you all to the Data Structures and Algorithms lecture number 1. So let's start the video. So in this video, we will cover the theoretical aspects of data structures and algorithms. So in this lecture number 1, we'll cover about what is DSA. So what is that? So data structures and algorithm is a way to store and organize data in the memory. So how can we store the data and organize it? It's the essential form that how to store the data and how to organize it, and for these reasons we use data structures and algorithm. And as per the name indicates itself, the data structure and algorithm, it means organizing the data in the memory. So in the memory we store the data in various forms, that is linearly and non-linearly. We'll talk about it later, but moving on, the data structure is not any programming language. You can use it in Java, C, C++, Python, or any other language. It's just a way to store and organize data, and this way can be applicable in any language you may think of. We will cover about the pseudocodes because pseudocodes cover about the logic used in the programming languages, and the logic is quite same and quite similar to all the programming languages. So programming languages are not a concern to be in data structures and algorithm classes. So algorithms are the way of solving a problem. So data structures and algorithms. So structuring the data and organizing and storing that in the memory. And algorithm is a way, the way or the steps that we need to do a certain thing. So data structures and algorithms that we can use in any programming languages. So data structures and algorithms, basically we cover that. And if we divide data structures and algorithms, so DSA can be divided into primitive data structure and non-primitive data structures. So primitive, and I'm writing non-primitive, non-P. So you can understand. So primitive data structure, in primitive we have the integer and then the character, then float, then we have the double, and we can also include the pointer in it. And in non-primitive we have linear and non-linear data structures. So linear and non-linear. This is all about it, and throughout in this video we will cover the data structures and algorithms basics. So in the linear data structure, the arrangement of data is linearly, in the linear fashion. That is, in the case of a linked list, it is arranged in this way. And for arrays, we use the indexation and 0, 1, 2, 3 and so on. And in stacks, it is arranged one after another like pile up plates. And in queues, we arrange like if the person who comes first is served first, first come, first serve, first in, first out, and here it is last in, first out, and here it is first in, first out in queues. Okay, so it is all about it. And moving on, so in linear data structure, in linear data structure, the arrangement of the data in the sequential manner, the arrangement is done in sequential manner. That is one after another. So the arrangement as it is done in sequential manner. So the examples are arrays, linked list, stacks, queues, and others. And you can also include some others like the arrays can be divided into 1D array, 2D array, and 3D array, like that. And in this data structure, one element is connected to one another element, like we discussed before. The element here is connected to this element, and it is also connected to this element, that is previous and next, and likewise in linked list next. So this one is head and this one is next. We'll talk about it later. And in arrays also we have the next element connected with the previous element, and thus they are connected to one another. The basic thing about it is clear that they are linear data structures. So linear data structures, the basic thing is clear, and they are in linear form. So as they are in linear form, so when we arrange that, the form is itself linear. So in non-linear data structures, we have trees and graphs. Previously, it was connected to one element, one another it was connected. But now it is connected to n number of elements. In a graph, it is connected to n number of elements, and thus the connection to one another element is not limited to only one element, it is unlimited and it can be connected to n number of elements. So that's the basic difference in between the nonlinear data structure and linear data structure. When one element is connected to n number of element, is connected to n number of elements. Okay, so this is connected to n number of elements, and thus this is different. So in this example, the elements are arranged in random manner. So random arrangement, and thus the arrangement differs for different kind of data structures. Like we can talk about the algorithms and abstract data types. Algorithms and abstract data types. So algorithms can be further divided into abstract data types, and abstract data types can be further divided into a set of rules. So algorithms are the way we do certain things and the way we solve the problem, but it can be divided into abstract data types, which is a sequence of problems or sequence of steps that are needed to solve the problem, and as a whole, as collectively, they are called as an algorithm. So algorithm can be divided into abstract data type, or I can write ADT, and then it can be divided into set of rules. So this is the basic hierarchy of it. Algorithm to abstract data type, and then it forms the set of rules. Moving on further, the structure, the data structure in the memory, where n number of algorithms are proposed. When we use n number of algorithm, so abstract data type helps us to define which algorithm is used at what position, or at what point, or at what problem we are concerned about, to structure the data in the memory, so that to structure the data in the memory, n number of algorithms are proposed. So algorithms can be many, n number of algorithms can be proposed, but if the all algorithms are to be used, then it can be used in the specific purposes or for the specific problems, not every time. So all of these algorithms are known as abstract data types, and all the abstract data types are further known as the set of rules. We will talk about it later and precisely. So next is the abstract data type, and it tells what is to be done. What is to be done? It's told about the abstract data type. So abstract data type instructs what is to be done, and data structure tells us how it is to be done. How it is to be done. So this is the basic difference of it. And moving on, we can have what is data. So talking about what is data. So data can be defined as the elementary value or collection of values. So data is a collection of values. It can be predefined as a value, but it's a collection of value. So value collectively is known as data. Data which can be processed and which can be used for a certain thing, or it can meet certain demands or certain criteria, then it's known as an information. Information which can be used for certain needs, then it's known as information, valuable information, or it can be stored into a file which can be further divided into certain parts of elementary processes. So this is the data. Data is a collection of values. So it's a collection of values. And then about what are records? What are records? So what are records? Record can be defined as a collection of various data types. So you can know about collection of data. Okay, so this one is data, and record is a superset of it, that is, it's a collection of data. Record, when it's collected and when it's formed as a collection, then the collection is termed as a record. Record can be defined as a collection of various data. So for example, we can have the name of a student, and the name collectively is known as the name of a class student. A class of student have name and the roll number, the section, everything is combined, and the collective data is known as a record. The marks of a person, the marks of a student are stored in the database, and thus it's stored in the fashion. So what is a file? Let's talk about a file. The file is a collection of various records. So this one is data, then it's formed as a record, then the record is further stored as a file. Okay, so this one is all the hierarchy about. The hierarchy is like the data when collectively is known as record, and the record when in many and it's stored as one single form, one single entity, then it's known as a file. If there are some employees in a class, if there are some employees in an office, and there are 20 records related to that, so the file of record which contains the info of all the employees, that would be called as the file. So the file is collection of all the records of the employees of an office. So talking about the attribute and entity. Attribute and entity. Attribute and entity, what is that? So an entity represents a class of certain objects. So an entity is a class of objects, but an attribute, each attribute represents particular property of that entity. So it represents particular property of the objects. So they are linked by this. So objects, when grouped together, they are known as entity, and the entity, the property, is known as attributes. Or you can also say about it like this: objects are a part of entity and attributes are also a part of the entity. And you can also form it like that: if it's the part of an object, then this is the attribute or the particular property of the entity. So this one is the most clearest form and the most appropriate form, because here I have not included the intersection. There are some intersection between them, because that's the property of an object. As it's a property of an object, so there should be an intersection. So this one is the appropriate one, this one is the right one, and please consider this one, ignore this one and this one. This one is wrong and this one is the correct form of it, because they have some interrelation between them, as attribute is a property of an object. So what is the need of data structure? The need of it. When the applications are getting complex and when we have to store the data in a much easier form, much simpler form that the person, a layman, can understand, then we use data structure. And for the certain reasons like the processor speed, one major concern is the processor speed. The processing speed, as the data is growing day by day and 1 billions of files are to be executed and to be studied, so we have to form an entity and just consider the basic information, the basic data which are considered to be essential or meaningful, they only are considered, and then the processor speed is also utilized at that moment. And data structure is also formed considering an inventory size of a high amount of data to be stored and a high amount of data to be transferred. So an inventory is also considered and it's also judged accordingly, and thus data structure are playing an essential role in forming the data, in judging the data, studying the data, encapsulating the data and utilization of it in the basic principles like polymorphism, encapsulation, then different forms of the OOPS principle, like encapsulation, polymorphism, and inheritance, abstraction, we can use that. And multiple requests are also being performed. And for that, we can use data structures. And if thousands of users are searching for a single thing, then the processing speed might increase, and that may lead to delay, or that might lead to dirty read. Dirty read is like when we search data which is desired, but we don't really get the data that is desired, or that we try to fetch from the system. We try to fetch something which is not related to the output that we receive. The output received is not the thing which we try to fetch. So that's a dirty read problem. We will study about it later, but that's a dirty read problem. And to solve these problems, data structures are used. Data is organized to form a data structure in such a way that all items are organized and are not required to be searched, and they are individually not searched. They are searched in a certain way that's decreasing the time complexity, and also optimizing the space complexity of it, so that we obtain the data in the minimum amount of time, spending the minimum amount of time, and not taking up much memory space, which is quite expensive if we consider large amount of data. Advantages. So considering the advantages, the advantages of data structure, that is efficiency, reusability, and abstraction. We will talk about it, like what is efficiency. If the choice of a data structure for implementing a particular abstract data type is proper, it makes a program very efficient in terms of time and space. So we are kind of efficient in the way we spend our time on fetching the data. The time spent is quite minimal if you use data structures, optimize that, and the use of data structure is in a proper way. So we optimize the time and space. And reusability, the data structure provides a reusable factor. That means that multiple client programs can access the data using the data structure. Abstraction is the data structure specified by the ADT, abstract data type, also provides level of abstraction. That is, the client cannot see the internal working of the data. It can only see the data which is intended to be visible to the client or the end user of the program. Data structures were classified into primitive and non-primitive data structure. Then we can further classify it, and here it is, the classification. So data structure can be classified as primitive and non-primitive. And in non-primitive you have the linear, non-linear, and in linear we have the static and dynamic. And in non-linear we have tree and graphs. In static we have arrays. In dynamic we have linked list, stacks, queues. Okay, so this is all about it, the hierarchy of it, about data structures. So operations on data structure, what can we do with data structures? What can we do? We can traverse. Traversing, like every data structure contains a set of data, and set of data structures can be traversed. The data structure means that visiting each element. Traversing means visiting each element of the data structure in order to perform some specific operation like searching or sorting. So in traversal we can use searching or sorting, and for that purposes, for that reasons, we use traversal. Traversal, if you need to calculate the average age of a person of a company, then we can also traverse the entire ages of the employees. And then if the entire ages are accessed and if the entire ages are compared and judged, then we can find the average age of each employee in the institution or the company. And if we have to calculate the average marks secured by a student in 6 different subjects of a class, then we can find it by traversing and completing the array of marks. We can compute, and then we can find the output of it, and then calculate the sum of it. Then we'll divide the sum of with the number of students in the class, and then divide by 6 because we have to consider about the 6 subjects. Then the average marks secured by the student in each subject is found out, and that's how we judge this problem and we do it. Traversal is one, and then comes insertion. How to insert? Insertion can be defined as the process of adding the elements to the array or the data structure at any location. We can do that in arrays or linked lists or stacks or anything we like, because the data structures are universal, and it can be, the principles can be used in any data structure you want, because in trees also we can insert in graphs, you can insert in arrays, you can insert in stacks, you can insert in linked lists, you can insert in queues also, you can insert. So insertion can be defined as the process of adding the elements to the data structure at any location. At any location, if we're adding something, then the insertion is termed as this fundamental method of adding an element at any position in an array, linked list, stacks, or any other data structure you may like to do. Deletion, simply deleting an element in any data structure. The process of removing an element from the data structure is called as deleting. So deletion, we can delete an element from the data structure at any random location. At any random location we can do that. And if we try to delete an element from the entry data structure, then underflow occurs. If we try to insert above the optimized or the specified level of the data structure, then that's called an stack overflow in the cases of stacks. So that's a overflow phenomena. But here if we try to delete from an empty data structure, then that's underflow. Then we can search. Searching can also be done like the process of finding the location of an element within the data structure is called as searching, and by that we mean that we can search it. Then sorting, ascending order, descending order, likewise when we did in the school. The process of arranging the data structure in a specified order is known as sorting, and there are many algorithms that can be used to perform sorting. For example, insertion sort, selection sort, bubble sort, and many others. Merging, we can also merge the data structures. Merging, when two data structures such as of list A and list B of size m and n respectively of similar type of elements are clubbed or joined together, then we form the list C. So list A and list B are merged to form the list C, and the size is m plus n. The size becomes m plus n as both of them are merged, and this process is known as merging. So this was all about the data structures and algorithms and what can we do with it, and this was a kind of introduction to it. And moving on to the algorithms and all, we will discuss that in the next class. And I hope you liked the video, and next video we will talk about the structures and all. So I hope you like the video. So that's all for the lecture number 1 of data structures and algorithm series. I will see you in the next video. Till then, goodbye.